Each winter, Wilderness Workshop partners with fellow nonprofits Aspen Center for Environmental Studies and the Roaring Fork Audubon to co-host the speaker series. As I mentioned earlier, this is unfortunately our 5th and final talk of the series, but they've been taking place every other week, January through March, here in Wednesdays at Carbondale, and then up at ACES Holland Lake on Thursdays. I'd like to take a minute to thank our Natural Science sponsors, especially our gold level sponsors. We've got Reese Henry, Clark Smark, and Ken Ransford, who is the presenting sponsor of tonight's presentation, as well as our silver level sponsors, Aspen Square, Ute Mountaineer, Blazing Adventures, Cripple Creek Backcountry, Bristlecone Mountain Sports, Aspen 82, Aspen Ski Co, Village Smithy, Bonfire Coffee, and Two Leaves in a Bun. Grassroots TV will be live streaming tonight's presentation on their website and on Wilderness Workshop and Aspen Center for Environmental Studies Facebook pages. Aspen Public Radio and KDNK will also be broadcasting tonight's presentation at a later date. And you can always find recordings of previous natural science presentations on Wilderness Workshop and ACE's YouTube channel. So keep your eye out for that. We usually try to get them uploaded within a week. So Wilderness Workshop has been super fortunate to do a lot of work with tonight's speaker, who's ecologist Delia Malone, in our efforts to protect the wetlands of the Homestake Valley, which for folks who may not be familiar is more over in the Red Cliff and Minturn area. It's absolutely spectacular, but unfortunately it faces threat from a potential new dam and reservoir, and it threatens to inundate portions of this incredible valley. Dee has been one of our experts in an ongoing community science project we're running in partnership with the Eagle River Watershed Council and a whole host of other organizations to document the biodiversity of plant and animal species in the fen wetlands of the Homestake Valley. Dee will share a lot more about what a fen wetland is, but just know that they're incredibly important to climate resiliency and to biodiversity. This summer, we're going to be hosting another Community Science Day up there on Saturday, July 8th, which seems really far away, but mark your calendars. But we encourage anybody going up to the Homestake Valley to join our project using the iNaturalist app. And you can photograph and log any plant and animal species that you see along the way. As you're walking out tonight, we have a QR code that folks can scan, and it will take you to our iNaturalist project so you can get some more information. Being involved in this critical information really helps us build the case for why these wetlands are so special and deserving of protection. We'll also be hosting a free guided snowshoe in the Homestake Valley. That's coming up a little bit sooner. That will be this Saturday, where participants can learn about the threat that a new dam would pose to the valley, as well as the generations of activists who fought to protect this valley from similar efforts. That will be this Saturday, March 11th at 10 a.m. You can visit our website for more information on our remaining winter programming, as well as our efforts to protect the Homestake Valley. And now, without further ado, I'd like to introduce tonight's speaker, Delia Malone, also known as Dee, is an ecologist at the Colorado Natural Heritage Program. As a field ecologist, she conducts biological surveys of upland, wetland, and stream habitats, and biological surveys for rare plants and animals across Colorado with the goal of conservation. Delia is also the wildlife chair for the Colorado chapter of the Sierra Club, vice chair of the Roaring Fork Audubon, and is a passionate advocate for preservation of all things wild. Please remember to hold your questions for Dee until the end of the presentation, when we will do a brief Q&A session. Thanks, and please welcome Dee.
Wow, thank you so much. It's so good to see so many friends here and new friends. Thank you for joining us. As Erin mentioned, the impetus for tonight's topic is the Homestake Valley and protecting and preserving those wetlands from being drowned by another dam so that that water can be diverted over to the burgeoning Front Range. So I am going to talk about fens. Fens are ancient wetlands. They are rare wetlands, and they are irreplaceable wetlands. So we're going to do a little bit of an overview. We're going to talk first about what are wetlands. Then there's a particular kind of wetland called a peatland. So what are peatlands? There are several kinds of peatlands. So we'll talk about what are a fen, which is a type of peatland. Where can we find fens? What types of fens there are? There's many. The value to us of fens and wetlands, and the value to biological diversity, the need for fens and wetlands, the threats, there are many, to fens and wetlands, and finally I want to talk about that relationship with regard to the Homestake Valley. And so I want to there's a lot of information here. I'm going to go over it somewhat quickly. Please have questions for me at the end. There's a lot to dive into, and please join us this summer in the Homestake Valley for the BioBlitz. What's a BioBlitz? A BioBlitz is us going out and identifying everything that we can find. Insects, plants, birds, amphibians, mammals. If we don't know something that's there, that something is there, we won't know to protect it. And that's the goal. Let's find out everything that's there. We can make the case, I know we can because this is a spectacularly beautiful area, that it needs to be protected. It deserves protection. And when we know it's there, we can protect it. So, what is a wetland? By definition, wetlands are lands transitional between terrestrial and aquatic systems where the water table is usually at or near the surface of the land, or the land is covered by a shallow water. So there's three primary criteria: that the land is saturated at some point during the growing season, that the substrate, the dirt, the soil, is predominantly undrained hydric, that simply means anaerobic soils, and that the plants there are predominantly characterized by hydrophytes, water-loving plants, plants that have adapted for their roots to be submerged for at least 14 days. They have special characteristics that enable that. Interestingly enough, only about 2% of the land in the arid West is wetland. That's about half of what it was from the 1780s till now. We've lost about half of our wetlands in the West and in Colorado due to various kinds of development. Protecting the remaining wetlands is essential. So, kinds of wetlands in the southern Rocky Mountains. There's a lot, but these are a few of the main ones. So, when we talk about wetlands, we wouldn't have wetlands unless there was water. So hydrology is the most important factor that controls the development of wetlands. And it not just the water, but the timing and the duration and the abundance of inundation will determine the type of wetland. Water affects more than just what's on the surface. It also affects the abiotic part of the ecosystem. In other words, the minerals, the non-living part. So depending on what the surrounding geology is, will determine the type of nutrients in the water, which will determine the type of plants that are growing in that wetland. So for instance, we have marshlands. Marshlands are formed in depressions in the landscape. They are generally inundated all the time. They are generally filled with water all the time. The bottom of a marsh is mineral soil derived primarily from rock, and the plants are emergents like cattails. There's wet meadows. The soils are saturated, but without standing water. The soils are again mineral, and typically grass-like plants called graminoids are what dominate in wet meadows. We have riverine wetlands, simply the wetlands that are adjacent to the thin strand of wetlands that are adjacent to streams and rivers. And those are typically cottonwood trees and willows and birch. Again, the soils are mineral, derived from rock and the surrounding geology. Finally, we have a wetland called peatland. Peatlands are peat accumulating wetlands. In the West, we call them fens because there's going to be a difference between the peatlands in the East and in the West. Those peatlands do not have mineral soils. Those peatlands, their soils are dominated by organic, what are called histosols. Important in looking at these kinds of wetlands, and there's more in Colorado. These are the main ones that we have up here in the mountains. Each of these wetlands supports a different community of animal species, a different community of plant species. So when we have all of these wetlands in an area, as we do in the Homestake Valley, we have a mosaic of wetlands. We have a consequently higher biological diversity of plants and consequently higher biological diversity of animals. We all have heard the dire news that biodiversity across the planet, and I can guarantee you that in Colorado, is crashing. By protecting the plant communities, we can protect the animal communities, and we can actually begin to enhance and even restore biodiversity. So, what is a peatland? A peatland is just a wetland that accumulates decayed plant matter. That's all peat is. Peat is partially decayed plant material, twigs, leaves, roots, and so on. Peat forms very slowly over time. It occurs when the production of organic material, in other words, the production of leaves and twigs, is greater than the decomposition. So we get this constant accumulation. And why does that occur? That occurs in these special wetlands due to saturated soils. Saturated soils inhibit oxygen, and oxygen, when oxygen is limited, decomposition is limited. And so consequently, in these places where soils are saturated, the decomposition of the plant material is inhibited, and the plant material accumulates to form peat. Plants in these peatlands, like in this peatland here, in this graminoid peatland, graminoids just grass-like plants, the plants are rooted in the peat. They derive all of their moisture and all of their nutrients from the peat. So, a couple of types of peatlands. We have bogs and we have fens. Bogs occur primarily in the eastern United States. They occur all across Canada. They occur up in Alaska. They occur in Ireland and places where there is a lot of precipitation and there is low evaporation. Bogs are nutrient poor because most of the water that comes to sustain the peat in the bog is nutrient poor. It comes from rain. Bogs also typically have a low pH. That's just the ratio of acid to neutral to basic water quality. The plants that persist in bogs, the bogs have a fairly low biological diversity. They have an inordinate number of insectivorous plants. Because there is low nutrient in the bog, they have to get their nutrient from somewhere else. Well, insects provide good nutrition. So we have a lot of insectivorous plants in bogs. They do not occur in the West. Why not? Because we have too much evaporation. We have a very dry climate. There is simply not enough precipitation in the form of rain to support bogs. We do have fens, a peat accumulating wetland. It's the only type of wetland that we have it's the only type of peatland, sorry, that we have in Colorado. And these peatlands, these fens, depend on ground and surface water inputs. They're minerotrophic. Minerotrophic simply means that the nutrients come from the groundwater. So as the snow up on this ridge melts, that snow melt infiltrates into the rocks, percolates through the rocks. As it percolates through the rocks, it dissolves some of the minerals and brings them down into the depression at the base of this valley. And that's what begins to form the fen. So fens are rich in dissolved minerals. They typically have a higher pH than do bogs. They have higher plant species richness, and they're dominated by graminoids. They occur, I find fens all the way from the alpine all the way to the upper montane. We don't really find them down here, and we'll find out why in just a minute. So, what is a fen? We have wetlands, we have peatlands, and then a particular type of peatland is a fen. Simply, again, a peat accumulating wetland that's fed by mineral-rich surface water or groundwater that generally comes from snowmelt. Their soils are peat, technically called histosols. They're primarily consisting of organic material, leaves, twigs, and so on. Fens, by definition, have to be greater than 40 centimeters deep, or it's not considered a fen. The accumulation of peat to that depth requires constant soil saturation and cold temperatures. Soil saturation to inhibit oxygen, to inhibit decomposition, and cold temperatures also to inhibit decomposition of the organic material. So fens can be characterized, because we're going to find out that there's a number of different kinds of fens, by the hydrologic regime. So how much water there is, when you get the water, the duration of the water, and so on. They're characterized by soils. So yes, all fens have peat, but there's various stages in the decomposition of peat. So we look at the characteristic of the peat soils and the vegetation. Depending on the characteristic of the water, what kind of nutrient it has, how acidic or how basic the water is, depending on the soil, will determine the kind of vegetation, and then the vegetation will determine the kind of the animal life that can survive in that fen. So fens are ancient. That's why they are irreplaceable. Never in our lifetime will we create a fen. So peat accumulation in the arid West occurs at about a rate of 4.3 to 20 centimeters per 1,000 years. That means that the youngest fens are 2,000 years old. So if, in other words, if you have to have a minimum of 40 centimeters of peat to be characterized as a fen, and the fastest accumulation is 20 centimeters per 1,000 years, then the youngest are 2,000 years, whereas the oldest started forming at the end of the last glaciation and can be upwards of 10,000 years. So again, the soils are peat, called histosols, where the primary component in a histosol is organic material rather than mineral. Mosses, herbaceous material, and so on. They have to be saturated, and during the dry season, July and August, the level of the water cannot decline or cannot recede more than greater than 30 centimeters below the water table. And they have to have an accumulation of 40 centimeters. So how do we know that that occurs? Well, in this picture right here, my partner in crime has dug a soil pit with a sharpshooter shovel, and we dig down and we take the plug out, and then we analyze what's in the plug. And so we see how deep we can go before we hit either dirt or rock. And if we can get 40 centimeters, we keep going. And we look at the bottom of that soil plug, and we see what it's composed of. So for instance, often we can see fibers of moss. Now, if you think about this soil plug, at the bottom of that soil plug is at least several thousand years old, whatever is at the bottom. And we can still see, we can distinguish moss fibers, we can often distinguish leaves, so much so that we could actually identify the species of plant that is at the bottom. So the decomposition has occurred really slowly, if at all, because of saturated cold water that saturates the soils. In that sequestration of plant material, we're also sequestering carbon. When that carbon is stored, it's not up in the atmosphere. So peatlands, peat, and fens are an important carbon storage device and act to mitigate excessive carbon release up into the atmosphere, which is one of our causes of an excessively warming climate. We can see in this plug right here, if we look closely, we can see and we can actually identify species of plant down here at the bottom. So 40 centimeters is about up to my knees, about 16 inches. Down at the bottom there, that plant material, it's kind of an amazing thought, but that plant material was laid down 10,000 years ago. Very special kinds of plants often grow in fens. We often see the dominant plants such as graminoids, sedges, rushes, grass-like plants like this cotton grass, the Eriophorum. Conifer forest can contribute to peat formation. Shrubs like this what is this common name? It's Kalmia, bog laurel. Sphagnum moss is a really important contributor, makes an important contribution to fen formation. So these are the kinds of plants that are typical in fen ecosystems. Fens need water. What maintains fens is cold, abundant, constant duration water. They're dependent on water to prevent the excessive decomposition of the peat body itself. They're dependent on the snowmelt to bring them the water. They're dependent on the snowmelt trickling through the surrounding rock to bring them the nutrients. No site in Colorado, no fen site in Colorado can persist on precipitation rain to maintain sufficient soil saturation because of our warming climate. What we'll see when we talk about climate warming is that we see that our precipitation in the Rockies, the amount of precipitation isn't going to change that much. It's really very difficult. What's going to change, and what is changing, is warming. And warming, of course, causes excessive evaporation. And that dries out soils. That is going to be the key to this. Snow is changing, the duration of the snowpack is shortening, changing to precipitation, and that is insufficient to maintain fens. So how much water does a fen need to persist? Well, this is graph, oopsie, what did I do? Oopsie. No. Does that work? No.
Got a backup if we need it.
I think I just touched the wrong thing.
Here, I'll trade you. Try that one.
How's that? That's better. Okay. So we have this graph here, and in this graph, we're comparing 5 different kinds of wetlands. 2 fens and 3 wet meadows. And at 0 up here, what we see is the water table. And in both of these fens, the water table stays at or very near the surface and only drops down in the warm months of the year, July and August, to about 10 centimeters below the water table. Whereas in these wet meadows here, during the dry months of the year, the water table drops all the way down to down to 140 centimeters from the surface. So we can get an idea from this on just how important constant soil saturation is for the maintenance of these fens. Where do we find peatlands and where do we find fens? Well, peatlands are found, we can see in the green area are peatlands. They're found again wherever precipitation is high and evaporation is very low. In the eastern United States, we have a lot of bogs, peatlands. In the west, we can see in this light yellow area in Colorado and a little bit up into Washington, a very slight, small area where peatlands, fens, are focused. Where in Colorado do we find them? Primarily at high elevation. That's where we see the majority of our snowpack. That's where we see the slowest melt. That's where we see the most moisture. coming in even a little bit closer. So these are the Sawatch Mountains on the right of the screen, and the little black dots are documented fens where people have actually gone out and dug soil pits and determined that those are actually fens. The solid areas are documented fen areas. The black dots are people have actually gone out and dug. We have fens up here in the Grand Mesa. Unfortunately, many of those fens have been dredged out and mined for peat. So when you go to the garden store and you buy peat to mix into your garden soil, some of that peat has come from local fens that have been mined out, although that is supposed to be not done anymore. Down here in the eastern San Juans, we can see all this high elevation habitat where there are documented fens. So, digging down a little bit closer, where exactly are fens located on the western landscape? So, we need enough water to perennially saturate the soils. We need plant growth that exceeds decomposition, which restricts fens to alpine, subalpine, and upper montane systems that have a landform that will capture and enable inundation of depressions. So thank you to the glaciers that sculpted this landscape, and they created this template that is conducive to fen formation. They created kettle ponds, and they left lateral moraines and terminal moraines like up in North Star Nature Preserve just east of Aspen. They created these sites where water could melt from the surrounding mountains and be captured and held on to enable the formation of a fen. So terminal or lateral moraines, like up in North Star, they block the water. North Star Nature Preserve used to be a large fen before the river broke through the terminal moraine. Bowls or kettle ponds. This site right here is a kettle pond over in Lump Gulch. And that kettle pond it has water coming into from the surrounding slopes. It doesn't have any outflow. And so we have sufficient plant material. We have the water to inhibit oxygen. And so we get the buildup of peat along the margins of this kettle pond. Flat valleys, such as the Homestake Valley, are ideal for fen formation. We have water coming in from the side slopes. We have a mosaic, depending on what's happening on the landscape on a micro topography level. We have a mosaic of ecosystems in the Homestake Valley. We have what we just talked about. We have wet meadows, we have riparian wetlands, and we have fen wetlands. Each of those providing a diversity of plants and a consequent diversity of animals, which increases the biological diversity in an area. The Homestake Valley is, a gem, and it's one of those places that deserves and needs protection. So a couple of the kinds of fens that we have basin fens. They develop in depressions in the landscape left by glaciers. And this particular one is up in the Mosquito Range. We can see in the diagram here we have a scooped out depression that the glaciers thankfully did. Water's coming in from the sides, from all sides. There's no place for the water to go, and so the leaves and the plant material that are deposited there are inhibited from rapid decomposition, and we start to get a buildup of peat. We have slope fens. They basically, we can look at the diagram, the water is coming down from the side slopes, and this is over by Breckenridge, actually, Swan Mountain. And we have the water coming in from the sides and coming into this shallow and low level slope, and again creating the conditions to enable the development of peat. We have this really lush cover of sedge this sedge that is a clonal sedge, which is really. This is a picture that's very similar to homestake. And again, we have all of this water discharging downslope from the snowmelt, ending up in this valley. And this is the fen, close-up of the fen that exists right there in this steep mountain valley. So glaciers created these relatively wide, like the Homestake Valley, like our valley, wide mountain valleys where we have this development of this mosaic of wetlands. We have springs, we have snowmelt, and we have, in this valley we can see we have grasslands here, sedges, we have forbs here, we have shrublands. Again, each providing a different habitat for different wildlife species, thereby enhancing biological diversity. So, and we have different kinds of fens, of course. And the difference in the fens and how they develop depends on the water and on the soils that the water from the snowmelt is flowing through. So we have what are called poor, and these terms refer to the amount of nutrient in the water, which is deposited in a depression, for instance, and determines the kinds of plants that grow in that area. So poor fens are nutrient poor. They typically have low pH, in other words, they're very acidic, and the plants that occur in these low pH poor fens typically are plants like bladderworts and sundews, which are both insectivorous plants that occur here in Colorado. We have iron fens, which are very rare. They have a low pH, but they're high in nutrient. Well, that kind of doesn't make sense, except when the water flows through geology of iron pyrite. The water dissolves the iron pyrite, creates sulfuric acid, and the sulfuric acid dissolves other nutrients out of those rocks, and that nutrient is carried down into the fen and provides situations for species like sphagnum moss, which is a really important fen-producing, peat-producing plant. Most of our fens in Colorado and the fens in our surrounding mountains here are called intermediate and rich fens. We have a lot of granitic rock, so we don't have a lot of acids being dissolved out. They're our most common fen. We have a tremendous plant diversity occurring in those fens. And then probably our most species-rich, plant species-rich fen is called an extreme rich fen. If you've ever driven through South Park, South Park is the place on the planet for extreme rich fens. So they're calcium rich. The water has come through like limestones and dissolved the limestone out, and that limestone comes into the fen. And we have species like this Greenland primrose, which occurs in Colorado, and the other place, it's very rare in Colorado, but it also occurs in abundance up in Canada and Alaska. So these plants, many of these plants are relictual. They remain here from the last glaciation when the conditions were much different. So they are relics of an ancient world. So this is an iron fen. This is sphagnum moss. Sphagnum moss is absolutely gorgeous. When in the autumn, it has this lovely, lovely orange color. And it typically occurs when it's fairly acidic in the soils. This is our typical intermediate fen. This is up at Independence Pass. And as you go over the pass, hopefully you'll have a new thought about this the next time you go over. But on both sides of the road, as you go over the pass, there's a rich complex of fens on both sides of the road. This is another fen down in South Park. This is a rich fen. And again, we have in this particular fen at the High Creek Ridge Fen, we have 14 globally rare plant species that occur there. One of the species is this little beauty right here called pale blue-eyed grass. So, what do we care? Some awesome plants, some amazing critters, but what does it do for us? Well, importantly, nearly a third of all wetland area on the earth are peatlands. It's a fairly large area, but fairly small. Consider that that area sequesters somewhere between 20 and 25% of the terrestrial carbon, meaning that they are make an important contribution to preventing further global warming. Conversely, if we drain them or get rid of them in some way, the peat body, if we drain the fen, if we get rid of the water, if we divert the water, that peat is going to start to decompose. And in that decomposition, it's going to release that carbon up into the atmosphere. So protecting and conserving fens, and all peatlands indeed, is critical to maintaining a carbon budget. Peatlands and fens, they store water. They maintain all that snow melt. Instead of it running off quickly, it's stored like a big sponge to be slowly released, maintaining flows in the rivers throughout the year. They cleanse water. So as water is flowing through the peat body, the soils and the plants, they sequester pollutants and they convert pollutants into materials that are harmless. And wildlife. Wetlands in general, although they only cover about 2% of the landscape, support better than 80% of our native wildlife during some time in their life cycle. So for many, many reasons, peatlands and wetlands in general have huge value for us and for themselves. So what particularly is the value of fens? Well, similar to peatlands, they support rare plant species like this. This is a little sundew. It's an insectivorous plant that lives over in the South Park Fens. We have a high diversity of plant and animal species in fens. They're very unusual, and unusual begets rarity. Basically, fens, you're thinking about how old they are, and we value old-growth forest. Fens are old-growth wetlands. They provide many of the same essential services that peatlands provide. They store water and improve water quality. They sequester carbon, and they provide habitat. Oh, just a little glitch. Hello. Next slide. Next slide, please. Aaron. Oh, Aaron. Or Grant. And that's where I got stuck.
There we go.
Okay, thank you, Grant. Okay, so really importantly, peat stores snowmelt. The reason you buy peat and you mix it into your garden soil is to improve the water holding capacity of your garden soil. So when you have these large bodies of peat, they are big sponges. So this photo is from up on the top of Independence Pass. And in this close-up photo, we can see. Oh, Grant. Oh, Aaron.
See if this one works. All right. I'm wondering if
I'm trying not to. I promise.
Luckily, we have 2 microphones. We'll just keep
Awesome.
swapping
Thank
about.
you. Thank you. Thank you. Okay, here we are. We're back. So we can see the water absolutely dripping out of this peatland, and I remember doing these soil pits up on the top of Independence Pass in July. A huge amount of water stored in these peatlands, which discharge out of breaks in the topography to supply our headwater streams that supply the stream flow in the Roaring Fork River. So maintaining these fens up there is essential to maintaining late season stream flows in the Roaring Fork River. This is, if you've all hiked up here probably, I'm looking down into where Lincoln Lake would be, and right above Lincoln Lake there are some lovely, lovely fens. And again, these fens are important to keeping the flows going in the Roaring Fork River during late season. Willow shrublands are often good fen producing sites. And in those willow shrublands, the wildlife is abundant. It provides great nesting habitat, it provides great food, it provides great cover. And here we have a little white-crowned sparrow nestling that is happy as can be in this willow shrubland fen up at Independence Pass. So I've been talking mostly about fens, but wet meadows are also critically important wetlands. And this wet meadow in Boulder County supports rare amphibians, including boreal toads, which is, they're becoming more and more rare. We have another type of wetland called, another type of fen that forms in basins called floating mat fen wetlands. This is up in Jackson County, and amazingly enough, this particular fen floating mat wetland supports 3 rare amphibians, wood frogs, northern leopard frogs, and boreal toads. Plus a whole host of rare plant species like this livid sedge and numerous others. This is a fen up at Warren Lakes. And Warren Lakes, if you may or may not know, is a big fen complex above Aspen. The water that comes out of Warren Lakes flows down the slope and into the Roaring Fork River again. One of the fens at Warren Lakes was dredged out, mined out for peat several decades ago. They've tried to do some reclamation to stop the outflow of water. There's still a few fens remaining, and this cotton grass, russet cotton grass, is common up there. It's a fairly rare plant species in the rest of the arid West. Another depression, glacial moraine, by the glaciers created this depression and a fen formed. This is above Ivanhoe Lake with these lovely, lovely yellow pond lilies, which is another fairly rare species in Colorado. So what are the threats? There are many I mentioned. First, and importantly, fens take thousands of years to form. Once destroyed, they will not be recreated in our lifetime or the lifetimes of many of us. They're tightly connected to groundwater systems. Any alteration to the groundwater or to the vegetation will negatively impact fens. So if we impact one, we impact the other. Because we're in the arid West, fens are especially sensitive to the groundwater supply. So impacts, negative impacts, result from both direct and indirect alteration to our habitat. This is up at Ivanhoe Lake. This is a fen on the, am I right? Yeah, okay. On the left side with all the elephant head flowers there, that's a slope fen. And what the people that own the water have done is to create a ditch. They've dug a ditch all along parallel across this fen. And you can see my partner in crime standing right here. And what that does is that the water that's flowing through that fen, because of the ditch, it comes out into the ditch, and then that water from the ditch is shunted over to Ivanhoe Lake, and the water in Ivanhoe Lake is diverted over to the Front Range to supply water over to the housing development over there. So that ditch drains that slope, and below that ditch, because the water has been diverted away from the fen, the slope fen below that ditch is drying and the vegetation is changing. Let's try this one. No, that doesn't work. Don't leave. Just stay right there.
There we go.
Okay, you just...
I'll hang out over here.
So this is actually Ivanhoe Lake before it's filled up. And what they've done to Ivanhoe Lake, which used to be a large fen, probably looked a lot like Lily Pad Lake. What they've done is they've dredged it out, they've dumped the peat on the side here, these big lumps, and they've let the water fill. And they did that to capture water, to divert over to the city of Aurora. I told you not to leave, Grant.
This is a new one.
So what are you doing? You're just going play from current slide.
Yeah, let's go down one though.
Okay, stay.
I'll stay closer this time.
Okay, again, if you alter the hydrology, if you change the water, that will alter the fen. But if you alter the vegetation, that will also alter the fen, because the vegetation acts as sort of a cap to inhibit excessive evaporation of the water that's supplying the peat. So in this situation, some folks thought it would be fun, I guess, to drive their ATVs, and in so doing, they of course destroy the vegetation, which then opens up, it's kind of like a wound, opening up the peat to excessive drying. This situation can be remedied. It takes a lot of money and a lot of time to do that. Okay. Ooh.
Let's just try. Let's just try clicking through like this. So you just click down each time.
Okay, I'll try that one. Okay, sounds good to me.
We're just going to do this for a minute.
Okay, thank you, Grant. If you alter the flow of water into the fen from the surrounding slopes, that will also alter and degrade the fen. In this case, this is over in Paradise Basin, over by Crested Butte, and we have this lovely dirt road that's going down into the basin. But as the water starts to flow downslope, it's going to be interrupted by the roads, and it's not going to reach the fen down. It worked. Elk have also had impacts on fens because through vegetation, elk love to wallow in fens. And this is a nice big elk wallow. So they've impacted actually both the vegetation and the peat, which will increase drying of the peat body and change the whole situation. Livestock basically do the same thing. They impact both the vegetation and they impact the soils. Again, once destroyed, once damaged, it can be repaired. It's very expensive, time-consuming, and difficult. Not just the other, but another impact can be in the surrounding uplands. So in this case, this is over in Gilpin County. The clear cutting has altered the flow of water down those slopes and into the fen at the base. So we see more evaporation, we see less infiltration of the snowmelt, and consequently not sufficient amount of water is reaching the fen. So there's the big monkey in the room, climate change. Basically what we're seeing, we're not having to even model this, what we're seeing is changing in the precipitation pattern. We're seeing changes in snow depth. Snow water equivalent is changing. The timing of the melt is changing. And the temperature in the Rocky Mountains are expected to impact groundwater-fed wetlands. So when we impact the source of the water that feeds the wetlands by excessive evaporation and by changing the hydrologic regime, we also can expect an impact to those wetlands that are supported by that snowmelt. So higher temperatures, which we are experiencing, will increase evapotranspiration rates and trigger earlier spring snowmelt, increasing spring flows, and so on and so forth. Basically, from modeling, what we're seeing is that when we increase CO2 emissions, peat soils will start to dry out. When peat starts to dry out, it means it's being decomposed, and it is contributing instead of mitigating the climate situation with carbon. And so we have this positive feedback effect. Positive not in the sense that it's good, positive that it continues to exacerbate the situation. We're reaching a critical threshold. We have a graph down here, and it doesn't look like we're warming too much in Colorado, except in Grand Junction, which for those folks from Grand Junction. So I won't say any more about that. But 2 degrees Celsius in our area may not sound like much, but it can threaten ecosystems and change landscapes, particularly wetlands, which are dependent on a particular snowmelt regime to maintain saturated soils. So with that, I want to kind of conclude with a little bit about homestake, because that was the driving factor about why we're here. We had this marvelous BioBlitz last summer. I hope you all can come out to the next one that we're having on July 8th, which is being hosted by Wilderness Workshop. This is the Homestake Valley. There is, if you look at the very head of the valley, there's already a dam up there. That's Homestake 1. It was fought tooth and nail, but you know, it's there. What they want to do is put a dam down here at the bottom of the valley and dam the rest of these wetlands and basically drown them. All of the values that we talked about, whether those values are for us or for those values are for native biological diversity, will be lost. The Homestake Valley is a marvelous mosaic of wetland ecosystems that supports a tremendous array, a rich array of biological diversity. I would welcome comments. I thank you for your attention. I thank you for your interest. And I thank you in advance for your advocacy to maintain Homestake as it is. So thank you very much. She's in charge.
I don't know if it's right or we will try. So give it a go.
I'll talk loudly. These dams that they're talking, this dam that they're talking about, will it produce hydroelectric power?
As I understand it, the primary purposes of the dam is to store water and divert it over to the Front Range. So hydroelectric power is not, as far as I know it, is not part of the reason.
Is the market for peat for home garden use and so on, does that have an impact on, a significant impact? Should we not be buying peat for our gardens?
Well, personally, I would say yes, you should not be buying peat. So, interestingly enough, and I'm not sure the year of this, but the Forest Service has and this is somewhat new, maybe a decade old, maybe more, but not too much more, has a rule, and they state that fens, that they understand what fens are to be protected because they are an quote, irreplaceable resource. So fens technically should not be being mined these days, although I know that they are.
Do you think, when you talked about elk and their influence on fens, do you think wolves would be a good introduction to kind of elk right now?
Okay, so that's, what do you think I'm going to say? So importantly, let me just answer that in a straight way. Elk have gotten very complacent without their top predator around. Elk kind of like all of us, we don't like to move and we don't have to. And that's pretty much what elk do. And when they can stand around, they can, and I'm not just talking about fens, but I'm talking about all wetlands, when they can stand around and they don't have to be cautious, they don't have to worry about a predator, they will do just that. And they will stand there and they will eat themselves out of house and home. And they will wallow and they will do that. So the primary impact that large predators, not just wolves, but any large carnivore has on their prey is to move them around. And so in a very straightforward way, the restoration of the most important keystone predator in North America to Colorado would, as we've seen in numerous other places, would improve the ability for vegetation to recover. So yes. Thank you.
Who or what organizations make the decisions to take the water from our area to?
Good question, important question. So the land right now where the proposed dam would be is U.S. Forest Service land, so it's managed by the U.S. Forest Service. They will be making the decision. It's complicated because the water rights are held by, and you'll correct me, Aaron, because Aaron knows more about the political situation than I do, but the water rights are held by the city of Aurora, is that correct? And Colorado Springs. And so it's a little complicated. It's further complicated because part of the infrastructure would have to be built in what is now designated wilderness. And so that is a big complication. That would have to be a change, a congressional change. But the thirst for West Slope water is huge. And they seem to be progressing, although we tried to get an update, but we haven't been able to do that.
So far, just so for folks' awareness, there has been no formal dam and reservoir proposal submitted by Homestake Partners, which is Aurora and Colorado Springs, but they've done some geotechnical drilling. They did that back in August of 2021. So they did that in order to kind of figure out if that area is geologically sound to put a new dam and reservoir. We haven't seen those results yet, either through the Homestake Partners or through the Forest Service, and we haven't heard anything yet about a proposal. So that's kind of where we are, but in the meantime, we're doing kind of everything we can to galvanize our community around protecting the really important resource that is there, which is the fen wetlands. Awesome. Well, thank you so much for coming, folks. I think my mic is